Hello, this chapter will be about trace and toxic elements. We will mostly be talking about iron, but there's a few others that we will cover. So the important thing to know is that when these are drawn, we have to pay really close attention to the collection, transport, and storage details because most of these tests that we're going to talk about in this chapter will be send-out tests to reference labs, and usually that there's a collection manual or procedure manual hooked up or tied to the lab information management system or the hospital information management system that tells phlebotomists and nurses how to collect these and how to store them, because it's going to be mostly send outs and it's going to take a long time to get the results back. So you don't want to delay that and mess up the storage and collection and have to have the sample rejected because of that. So the first element that we're going to talk about is aluminum. That will be a trace element. We won't get too many of those. Arsenic is one that we do need to pay attention to. It is exposed. We get that through exposure from diet, like food, especially seafood, and water. Lower amounts from other food and water. The important thing to know is that the symptoms are nausea, vomiting, abdominal pain, diarrhea, and that can lead to renal and liver failure. Exposure can lead to acute and chronic intoxication. And if you like to watch the Poisoners shows or Deadliest Women, that kind of thing, or movies, arsenic is a common poison that's used and discussed in those types of documentaries. Next is lead. Lead was mainly a big deal because it was found in paint that was used on cribs, baby toys, jewelries, and so those things have been recalled now, and we do not use lead-based paint anymore. There is no known function of lead in human physiology. It is always toxic. We can get exposure through respiratory or GI methods, and the big problem, so adults and in children, your IQ declines, you're clumsy, you have trouble walking correctly, headaches, behavioral changes, seizures, behavioral and cognitive problems. In adults, you will see peripheral neuropathy, so they'll lose the feeling in their fingers, toes. Their motor skills will diminish. And why is lead poisoning so bad? This is really important. It's because the majority of lead that's ingested or inhaled is taken up by red blood cells, and that prevents heme synthesis. So that's why lead poisoning is so bad. Mercury, I'm sure that y'all have heard about mercury, especially in relation to seafood. Mercury is non-essential. There is no known function in human physiology. The symptoms of mercury poisoning include headache, tremors, impaired coordination, and stomach cramps. And here the main points of exposure are inhalation. It could be in manufacturing plants. But for most of us, we are worried about the amount of fish that we ingest. That's important, especially for pregnant women. That's why they can't eat more than a limited amount of tuna fish during their pregnancy. The symptoms will be headaches, tremors, impaired coordination, and stomach cramps again. Copper is a little bit more interesting. It is essential. It's a component of some of our enzymes. We get it through our food. We can also absorb it 50 to 80% through our diet. And the deficiencies of copper can cause neutropenia, hypochromic anemia, osteoporosis, decreased pigmentation of the skin, and a general pallor. And that's important because on the flip side, a toxicity, you can have copper deposits in the skin, and so patients can get a very dark, coppery tan color. Wilson's disease is when there's a problem with copper transport or copper breakdown, and it builds up in the nerves. You get neurological disorders, liver dysfunction, and something called Kaiser-Fleischer rings in the cornea. And I have a picture for you here. So these Kaiser-Fleischer rings, here's the address where I found the picture, and this information came straight from Wikipedia. But Kaiser-Fleischer rings are the dark rings that appear to encircle the iris of the eye due to copper deposits in that part of the cornea. So it's this dark, coppery ring around the outside of the iris. All right, here we go. Iron. We need iron. It is essential. It's found in hemoglobin and myoglobin. We ingest it in our food, and it must be reduced to iron with a 2+ charge for absorption. That is the ferrous form of iron. So ferrous is iron with a +2 charge. We absorb 10% through our diet, and transport, this is important, is carried by transferrin. So transferrin is the protein that transports iron to the bone marrow, where it is incorporated into hemoglobin. Deficiencies cause anemia and increased levels in iron. It can accumulate in tissue and cause a problem with liver function, and also, again, hyperpigmentation. So next I'm going to switch to my notes, and they're also attached for you in Canvas. So let me see if I can. I'm going to pull it. All right, so now I'm going to read through these notes that I've made for you, for the students and for myself, and interpret my writing for you. Iron levels are diurnal, so that means it varies during the day. Early AM or early morning samples are best. Hemochromatosis. You will be talking about this also in hematology. Hemochromatosis is a hereditary genetic defect that causes tissue accumulation. It affects the liver and also can cause hyperpigmentation of the skin. So again, that will cause a darkening of the skin, so it looks like that you have a really bronzy tan. Again, it is found in hemoglobin. It is an essential part because this iron binds to hemoglobin, and this is what actually binds to the oxygen. This, if you think back to what general chemistry, probably even in high school, oxygen has a -2 charge. The ferrous form has a +2 charge, so it pairs perfectly together. Iron is stored as ferritin and hemosiderin. Those are two important storage forms of iron. Again, transferrin is the transport protein that transfers iron to the bone marrow, where hemoglobin incorporates it and allows it to bind oxygen. So iron deficiency anemia is one problem of iron deficiency. And then toxicity, too much iron can lead to tissue accumulation. And this can be through iron overdose, like somebody takes too many vitamins. That could be a problem, although rare. Sideroblastic anemia, and we will learn more about that in hematology, where there's a blastic anemia and it has iron deposits around the nucleus. Viral hepatitis, and of course hemochromatosis. So in the condition of hemochromatosis, the serum iron will be increased. For example, 250 micrograms per deciliter. The reference range for serum iron is 60 to 150 micrograms per deciliter. The total iron binding capacity, and I'll talk about this in a minute, it means that the total iron that could be bound is decreased to, for example, 250 micrograms per deciliter. Reference range for the total iron binding capacity is 300 to 350. And we do call this the TIBC in the lab. The ferritin, which is the storage form of iron, will be increased. For example, 350 micrograms per deciliter, and the reference range is 20 to 250. So in hemochromatosis, your iron is increased, your ferritin is increased, but your total iron binding capacity is decreased. That's because it's already bound up. It has no more capacity because it's bound up. All right, ferritin is the primary storage form of iron. It can be elevated in obesity, inflammation, and alcoholism. Serum iron, again, has a diurnal variation. And oh, look, you can see my secrets. T in a circle, test question. It is highest in the AM, in the morning. Transferrin, here's another test question, is increased in iron deficiency disorder. Okay, because there's more transferrin available to transport iron, but there's no iron for it to transport. And transferrin will be decreased in iron overload because it's all loaded up. And remember, transferrin binds the ferric iron. Hemochromatosis and severe infections, it's measured in the immunochemical way, and again, the reference range for transferrin, this is new. Transferrin reference range, 200 to 360 milligrams per deciliter. Ferritin will reflect iron stores early in iron deficiency, so it is an early indicator of the disease. Remember, ferritin is a storage form of iron. So ferritin reflects iron stores very early in iron deficiency, so it is an early indicator of disease. It will be increased in iron overload, hemochromatosis, and severe infection. Okay, so those are cases of increased iron. Again, the reference range 220 to 250. The total iron binding capacity, or the TIBC, measures the quantity of iron bound to transferrin. If all the binding sites on transferrin were occupied, we're going to go to number 2. The percent transferrin saturation is calculated value that represents the amount of iron that is capable of binding. So that explains the total iron binding capacity. So the percent transferrin saturation equals the serum iron in micrograms per deciliter divided by the total iron binding capacity in micrograms per deciliter times 100%. So the percent saturation of transferrin is 15 to 55. So here are the reference ranges. Serum iron, 45 to 160 micrograms per deciliter, and the total iron binding capacity, 250 to 425 micrograms per deciliter. Percent saturation, again, 15 to 55. So I hope these recorded lectures are helpful. You can pause them, rewind them, slow down anytime that you need, and they will be here for you.